Welcome to solving to the most complex mathematical questions that are well solved, well illustrated. Just keep tuned. So, good morning, class.
Good morning, sir.
So, today we are going to deal with the logarithmic function. We are going to deal with logarithmic functions, and we are saying that if, for example, you are given a function which is equivalent to, let's say, log x to base 2, we can write this function in another form by saying 2 power this function, which is y, will give us our answer as x. You can also be given another function like y is equivalent to log x base 10. It means it will be our 10, then power our y, you will get our x. So this will be the value of x, it will be 10 power y. So once again, you are told to show that log log x, let's show log what? Log xy base a, if it is equal to log x base a plus log y base a. So once again, what you have to know is that you can first let this one, you can let our a log xy base a to be v. So if it is like this, when you are converting this into this, the way I have shown you how to convert, basically you just get it is a power v will be equal to x y. Once again, on the other side, you can let this log x base a to be something like w. So log x to base a to be equal to w. So if we convert this like the way I have shown you to convert, it will be a power w will be equal to our x, and let this one to be our first function, let this one to be our second function, then lastly we have log y to base a to be equal to something like z. Let's use z now that we have not used here like x, y, so we have not used z. So once again, on conversion it will be a power z will be equal to our y. So that is it. The way it, on conversion, this will be our equation 3. So you have three equations. So the first equation we are saying it is a power v is equals to um, this second equation has given us a power w, and the third equation has given us a power z. So we were told to show that this one is equivalent to this. So if you are given any logarithm equation and you are given of the same base, you can just drop the bases. So the result will be v will be equal to w plus z. But what is our v in our question here? Our v was log xy base a, which is equal to our w was log x. It was log x base a plus z. But what was our z in our function? It was log y. It was log y base a. So this is basically what is shown. So you can say as shown. you have shown that this one is equivalent to this, and then you have shown how it has been equal. So once again, I can show you another one different from this. It will be log x over y base a. Let's use again base a. If it will be equal to log x to base a minus log y base a. So this is example 2. This is example 2. So once again, you can always let this part to be u. Let me let it to be u log a of x over y to be a. Let's say to be u. On conversion, it will be a power u will be equal to x over y. Once again, you check on log x base a to be equal to w, and you are getting it is a power w is equals to x, and finally log y base a to be equal to z or n number. So what are we getting? This one will give us our first function, second function. So let's just write them in the correct order. So we have u a power u is equals to, we are having w. On converting, we are saying it is a power w all over the last one will be a power z is equals to y. So a power w a power z. It is a power z. Remember, it is for y. So once again, when you have this, instead of writing this, you can always write as a subtraction. You can write as a sub. So it will be a power u is equals to, in division. If it's about logs, you can always subtract because you have same bases. So it will be a power w minus a power z. And if you have the same bases, you can just drop the bases and you remain with u is equals to w minus z. Once again, what was the value of our u? We said it is log of x over y, and the value of this was log x base a minus log y also to base a. So hence shown. So this is how to deal with logarithmic functions up to that point.